All right, even though the launch is a good one, it is a little too hard, guys, if I walked you through it. I really just want to go ahead and start, which is our learning goal for today. Big idea here, what does being able to exponent and equal allow you to do? I think as we go through, I will go back and add more so that you, I'm going to show you some, and then I'm going to do this focus question, because you'll get it till we look at it. All right, got quite the delay there. You guys on page, part 1 got it, on the 6 is where I am. If we look at this focus question, it says, which are equivalent. This word equivalent means good. It means equal. It has the root word of equal in it. Oops, can't do that. Okay, equal to 5. Okay, look at this one. First one. If I have 5 to the, what is that? 5, is that equivalent? No, it's not the same as 5. All right, let's do this number. What was the rule if I have powers over powers like this and these two have the same bases? What am I supposed to do? Subtract. So it'd be 14. Is 5 to the 14th equivalent to 5 to the 8th? No. Okay, what about number 2? What am I supposed to do here? Add them. So this would be 5 to the 8th. That is equivalent. So we're going to circle this one. This is a really nice view for us. Okay, what about 5 squared to the 4th? What do I do with powers? 2 powers. Distribute. Multiply. If I had more, I would distribute. So this would be 5 to the 8th, and that would be equivalent. Okay, so let's look back at the focus question and see if this makes a little more sense after we've looked at an example. It said, what does being able to write expressions with exponents in equivalent forms allow you to do? Okay, so this is going to allow us, it says writing expressions using common bases and exponents allows you to compare expressions. Okay, so we're going to be comparing them here in just a minute. Alright, so the second part that I want you to try, now that I've gone through this with you, can you write 4 expressions that are equivalent to 2 to the 13th? So I want you to try to write 4 of these in that same box. Use this as your sample. See if you can write me 4. So go ahead and do that right now. Alright, go ahead. What do you have on, give me one of them that you guys wrote down, because we have lots of answers here. Caleb. With parentheses? Okay. Okay, well, tell me what you guys think. What is that going to give you? 12. Chris, you need to sign up for that. That's going to give me 2 to the 12. Is that going to be equivalent? Oh, I thought it was 12. It's a 13. It's a 13. If it was a 12, that would work. All right, so let's try something else.
Sorry for the interruption. Choir 1 is returning. Can I please choir 2 to the music room? Choir 2 to the music room. Thank you.
All right. Kurt, okay, Lottie.
I did 2
to the 4th power?
Yeah.
Okay.
And then I did times 2 to the 3rd power plus 2 to the 5.
2 to the 5? Okay, so I might have to tweak it just a little bit. So 4 plus 3 would be 7. So if we want to, we got to add something else to 7 to get up to 13. So I'd need to add a 6. Now that would be an expression, because if I add, I'll get 13. Oh, I gotta love technology. The 5th power?
2 over 2.
There. What we figured out before. Powers, 2 powers. This is really fun. Okay. Any comments on that one before we move on? All right. Now, here's where we get into the comparing. So this expressions with exponents in equivalent forms allow you to do. It's going to allow us to compare. And when we compare, we typically use inequality symbols, which are greater than, less than, or equal to. All right, so let's look at this first one. So this is the got it box at the bottom of page 66. That's where I am for this one. All right, this is 9 to the 12th. And then 9 to the 36 over 9 to the 3rd. What do I need to do on this side? Kurt? Very good. Subtract. So this would be 9 to the 12th. And this side would be 9 to the 36 minus 3, which would be 33. Can you tell just by that which bigger?
Yeah.
Yeah, which one's going to be bigger? the 9 to the 30.
If the exponent is greater, and then if you try it out, it's bigger than
Right. There's no way that I want to do 9 33 times. I know that if these two have the same base, and I multiply it out 33 times, that's going to be bigger than multiplying out times. Okay? All right, let's look at the next. What do you guys think about letter A? Go ahead and write that one down. Sorry, I forgot you don't have this one in your book. In the same box. Be larger. What's this one going to be on this side? To the what power?
6.
No, be careful. What power? No. Fifth. Because you add them, right? So this is going to be 3 to the 5th power. So is 3 to the 6th bigger or 3 to the 5th? 3 to the 6th. So we're going to want our greater than sign in there. Okay, go ahead and write down letter B, and let's try that one. What do you think about this one? What's the rule when we have powers over powers? Subtract them. So this will be 7 to the 4th, and this is 7 to the 4th, so they are equal or equivalent. Alright, so then we get to these fraction ones. But don't let fractions scare you because they're the exact same rules. So if you write this one down, and we're going to simplify it. So this side is going to say 1/4 to the 16th power. These have the same base, so what do I do with my exponent? I add them. This is 1/4 to the 10th power. Okay, now this gets tricky. I want to show you guys something. What happens as I multiply out fractions? Okay, let's say this. Let's say I have 1/2, and I have 1/2 squared. Okay, what is 1/2 times 1/2? How much?
1/4.
No, multiply. Don't add them.
Oh.
1/4. I heard someone say it. 1 times 1 is 1. 2 times 2 is 4. Okay, now think about a pizza. Which is bigger, a half or a fourth?
4.
A half is bigger, right? You'd rather have a half than a fourth?
Yes.
So as you multiply fractions, they actually get smaller. Okay? So more times I multiply them, they get smaller. So which one is going to be bigger here? Okay, as I multiply them more, they get smaller, right? So as I multiply them more, this number will actually get tinier and tinier and tinier. So this one is actually greater because it has less power to it. Does that make sense?
Is that 14 4?
It's a, oh, sorry, I didn't mean to put 14. Thank you.
That's
It's a
why
4.
I was confused.
Oh, that's why you're confused. My bad. Okay, that's really tricky. The more times you multiply fractions, they actually get tinier. All right.
Because it's a decimal?
No, it's just because of this right here. If I have 1/2 times a half, it's really a fourth. Yeah. All right, so I want to go back to this focus question again and see if this makes sense. Okay, what does being able to write expressions with exponents in equivalent forms allow you to do? The big idea here is that when you can put them in equivalent forms, it allows you to compare them. Okay, so that's the big idea. That's what we were doing here. We're using equivalent forms. This is an equivalent form of this, but once we put it in here, then we can compare and decide which one is bigger and which one's smaller. Okay, so that was our big idea of our lesson today. All right,